is this plane currently nose down in this orientation?
Yes.
Okay. So when I'm here, do I need to do that in order for the plane to...
Okay, stop right there.
Yep.
Is that plane right now nose up or nose down?
In relation to your horizon, it's nose up.
So why don't you make that plane keep the same angle of nosing relative to the horizon as it goes around?
So I need to,
tip it up.
I need to nose down to do that.
That would be dipping down. That would be nose down.
Already done part
No,
of
no,
it.
no, 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 no. Show me. Go to the equator. Go to the equator.
Okay, without nosing down, correct? Without pressing the
No,
nose down button.
go to the equator.
Okay, without
with
nosing down.
what you call nosing down.
Okay, so
Okay.
now watch this. Jorge, watch. I'm going to nose down.
Yep.
And now I'm nosing down. There you go. Now it's nose down.
Now, let me ask you the question: is that plane nose down?
In relation to that, no.
Exactly. So nothing. So you just unproved yourself,
No,
brother.
but he had to nose down
Not
to do
nose
it.
down.
But he had to nose down to do that. Come on.
In order for me to fly around the globe, I needed to nose down. So if I don't nose down, this is what happens. But you said this is not how.
That's not what happens. Your little diagram there, you would lose the horizon to the bottom. And go like 3/4 of the way. Go half the way. Oh, stop. Now, right there, your altitude diagram is wrong. You cannot look out the front of that window and see that, brother.
Okay,
Come
so
on.
Let me show you the advanced one.
You
now.
are doing yourself
Let
a
me show you the
disservice.
This is
You're
the
doing a
advanced one.
disservice.
Advanced one. We're going to go to the advanced one. No worries. This is your globe. This is the correct dimensions of the globe. 24,901, 3959. All right. Now, does this instrument, which maintains rigidity in space, all right, does it align to gravity or does it maintain rigidity in space? Jorge, which one? Which tells the plane its pitch. Does it align to gravity vector or is it?
Yeah, it's going to align to gravity vector.
Okay. And you said we never need to nose down, and the plane pilots had all admitted they never need to nose down, and it doesn't show on the pitch data. Because if you were nose down, it would show up in the pitch data, correct?
Yes, I get you. Yes, if you had the nose down, it would definitely show up in the pitch down.
Okay, great. Okay, so welcome to Flat Earth. You're about to get pretty cooked here. I'm sorry, but all right. I'm going to take the plane off. It's going to fly.
Shit happens on the internet.
It's going to fly. I'm going to maintain a pressure altitude, so it's going to stay at the same.
Hey, stop, pause.
Yep.
Why did the horizon drop a little bit?
Because your Earth is curved.
Oh, sweet. All right, excellent. Okay, we're good. I like it. Go ahead.
Okay, good. So you said we never need to nose down. Now what I'm going to do is, it's on ×1 now. I'm going to put the plane, I'm going to speed it up to 150 times speed. And this is how fast the plane's going now. It's going 500 miles per hour, but I've sped it up 150 times. So now this is how much distance it's traveled. And this is what it looks like on your globe. Now, remember when I showed you on the easier one, when I went to the equator, it was facing away from the Earth. Well, you told me that this instrument aligns to gravity.
All right, stop. It's now nose up.
Correct, because you said we never need to nose down.
You need to keep the horizon at a certain level.
So I need to nose down.
So right now, the horizon cannot drift away from that line like it's doing.
So I need to nose down.
Well, you need to at least fly flat. You don't need to nose down, but you need to not nose up.
Well, hang on a second, Jorge. Do I need to nose down now?
How high? What's your elevation? What is your altitude?
24,000 feet. Do I need to nose down, yes or no? I told you.
From there?
Yes. Do I need to nose down?
You need to go to at least level. You need to go to the level, not nose down.
Not
positive pitch,
okay.
But you need to reduce your pitch a little bit. You don't have to make it negative. You just need to reduce it. No, you don't. No. Hold on. Pitch is a signed value, brother, and it's relative to the horizon. If it's positive, your nose up. If it's negative, your nose down. But if it's zero, it is perpendicular to the gravity vector.
Planes don't fly zero. Planes fly with a 2 degrees nose up always. And you said we never need to nose down. I can show you the pitch data to confirm this. Now, in order for me to fly around this globe, this is now the view from reference frame the Earth, okay? So now we're gonna. Okay, so I'm just gonna fly the plane now. I'm gonna resume.
And can you zoom out?
Yes. Let me know when I need to nose down. Here's the pitch.
Okay.
What's happening?
Is it maintaining a constant altitude?
Yes.
So you're good. You're flying at a constant altitude. What's the problem, brother?
That's good, is it?
Yeah, I mean you're flying at a constant altitude.
So is that how a plane flies? It just noses up away from the Earth constantly?
I'm not a pilot, but they probably nose up a little bit.
2 degrees. Do I need to nose down to get to 2 degrees? Jorge?
You need to lower your pitch some.
So
it's not going to be nose down.
Correct. So I need to nose. I need to do this. I need to do this.
That's still not nose down. That's flat.
That's not
pitch zero.
Hang on a second. I was here, and I went from here. Did I just nose down?
No, you reduce your pitch. You didn't.
They don't fly at 0 degrees. They fly 2 degrees nose up. I told to
And
maintain.
keep
lift.
it at 2 degrees, bro. Jeez.
I'll keep it at 2 degrees. Now we're going to resume. But you said we'd never need to nose down, so I'm going to resume it now. Yep, no worries. We're not nosing down. Oh, but the Earth is curving down and away from the plane, Jorge. So I might need to reduce that pitch. Let me know when I need to reduce it.
Stop. Just stop right there.
All right, stop it.
That is not 2 degrees nose up.
I know because I'm not nosing down to adjust for the curve.
Brother, you are measuring your pitch angle wrong. You need to measure it relative to the gravity vector. Why do you keep measuring it relative? No, you're not. You're measuring it relative to an inertial vector. Your gravity vector at the beginning, not the current gravity vector.
Look, watch this. I've traveled 1,390 miles, okay, over your globe from the North Pole to our starting position, which was here. Okay? Now, I'm going to turn this to rigidity in space. What's it going to show me? Oh, shit. Now it's showing that we're completely nosing down on the attitude indicator. Is that what happens in reality?
That instrument is not measured relative to that inertial frame. Not that instrument. That's a local horizontal
gravity?
horizon measurement.
To gravity. Local horizontal to gravity. Okay, great. Local horizontal to gravity. Let's resume it.
So my question to you, when you set it to 2 degrees, why is it not staying at 2 degrees?
Because I'm not nosing down, and you said we don't need to nose down, just like the pilot said. Welcome to flat Earth, Jorge. I'm going to reset it now. We're going to reset. Watch this. Just pay attention. This is your globe. This is the correct dimensions of the globe. I'm going to now fly the plane again.
Here's where I trick him and switch it to a flat Earth model.
I'm going to speed up the timer. Okay, I'm going to set a pressure level like before. Speed up the timer to 150 times speed. Right?
Yes.
And now the plane is flying. Okay? And it's even drawing the pitch data. Okay? Now, as the plane is flying, does it need to nose down on a flat surface? Is this how the plane... Wait, before you said the plane always maintains 2 degrees. Is this maintaining 2 degrees right now?
It looks like a yes.
Okay, that's a flat Earth. Welcome to flat Earth.
Oh.
Go to your globe model.
So you said...
5 degrees later.
All right.
Maintaining 2 degrees. Maintaining 2 degrees.
Oh, I need to nose down for that, boy.
No, you don't. You need to maintain 2 degrees relative to the gravity vector if you did your sim right, which I don't think you have it.
So gravity pulls the nose down?
No.
Okay, so what's pulling the nose down?
Trim.
That's what you just said.
Oh, trim.
Wait a minute.
Hang on, he just said trim. Hey, excuse me.
That's wild.
Hey, when they trim the plane, they trim it to fly in the exact same orientation. Did you know that?
I'll take your word for it. But right there, you have not maintained the same pitch angle. You need to maintain the same pitch angle.
Down. See, Hoy, if I press this button to nose down, is this better for you now? Is that better?
Okay. But you've maintained your pitch angle, right? And it hasn't gone negative. In other words, you have never pointed down.
I need to nose down. I'm currently nosing down as I fly over the Earth. Do you see the pitch data, how I nose down big? And as I'm flying, every time I nose down, it shows us up. Look.
Okay, so your nose down is a negative slope in your pitch, not a negative pitch.
Planes fly with a 2 degrees nose up in straight level flight. In order to
planes fly to maintain a pitch angle, and if you do that continuously, angels, if you do that continuously, you will not see the nose down.
It's 2 degrees pitch up.
If it never noses down, Jorge, how does it maintain 2 degrees if the Earth is curving down away from it?
Because it's continuously changing it. It doesn't even do it like...
No, it's not.
They said they're not changing.
Am I nosing down currently to adjust the pitch angle? Did I just nose down there? Is that now nose down?
I don't know. Is nose down decreasing your pitch, or is nose down negative pitch? Because that's negative pitch. That's if you nose down some more.
Okay, now there we go.
That's nose down.
Okay, so in order for me to fly around the globe, they don't have a nose down in relation to the horizon.
They go back up. Go back to 2 degrees.
They have a 2 degrees nose up to maintain lift. If they were to fly like this orientation, they would just lose altitude. The air, Jorge, has to go underneath the plane, not over it when they fly. They have to maintain a 2 degrees nose up. So I'm going to resume it now, Jorge. This is the correct dimensions of your globe. We're almost at the equator like you wanted. And look how many times I've nosed down. Look at that. Down, down. And then it's gain pitch, down. Every time you tell me not to nose down, it gains pitch. This is the 2 degrees nose up in relation to the horizon. I'm going to resume the plane flying. It's now flying again, okay? 2 degrees nose up, okay? Is this how it flies in reality? If we just keep going, is it just going to maintain a 2 degrees nose up?
So I just switched to backfill flat Earth model to trick him.
I think that's what Trim tries to do, right? Like maintain some kind of stable configuration where you have all the aero forces.
So this is correct. 2 degrees nose up, flying over the Earth, doesn't need to change pitch. Is that what you mean?
Yes, and that's relative to gravity. If you're flat Earth, if you're flat Earth, it is relative to straight up and down. If you're on the curved Earth, it's relative to gravity. It's the same thing.
Does this match what you said earlier? 2 degrees nose up as we fly. We don't need to adjust the
It's the
curves.
same thing.
Okay, so that's a flat Earth. Welcome to flat Earth. So what do you have to say to that, Jorge?